Where's my pen?
Well, hello, Julia.
Hello.
There, you got a pen. And let's see your assignment.
Okay, so the assignment is to have a drawdown of these.
Okay, there's the page right there. Assignment 2, Coalescence of Acrylic Enamels. Let me zero in on that. Yep. Okay, so your first one, and it's called CAE, an abbreviation of Coalescence Acrylic Enamels.
This one's, oh,
And A is just the
hard resin.
Just the hard resin by itself, right here on the drawdown. And so this just be the resin by itself.
Here's C.
Now you want to do CAE 2B and CAE 2C.
Okay, and then we're going to put 100 in here.
Yep.
And 100 in here. So let me go and tear it.
Oh, that's a good idea.
Yeah.
Yeah, you had it on. Okay, it's on 0 now.
Now it's on 0.
Okay, let's see. You put in 100 grams of each.
Okay.
And I see you have it labeled.
Yep.
Yep, 2B and 2C. And this shows 2A has the DPNB solvent, a very rich coalescing solvent. And 2C has propylene glycol, which is not a good coalescing solvent. And we'll see what that does to the film.
Okay, put in this one, yes?
Yes.
100 grams in each.
Yep, this is 604A. You look. Yep, 604A.
I see it.
This resin is at least 15 years old. Oh, there you go. Date 1700.
2000?
Yep, it's the year 2000.
12 years old. Well, 13 years old.
Yep, 13 years old.
Alrighty, so 100 grams. Here we go.
Amazing that it still works, huh?
Yeah.
Okay, there goes. You got 100.
Almost.
99.23, 101.3. So just write down 1.3 extra.
Yep. So plus, I could get it out, because this is the first one, plus 1.3. So check off, and checked off.
Good.
Okay, now the second one. I'll tear it anyway.
Better tear it again, yep.
Okay. And 100. Oopsie.
110.
Well, that one I will definitely get it out of.
And just pour it out from the top.
I like that. About 10 grams. Okay, that's about
6.
4. Two grams? Okay.
Be bold, be brave.
Yep. Conquer. Okay.
You're getting
2 more
there.
grams. Almost. Alrighty. Hold on. Now I have to be careful. Okay. We're leaving it at that, right? Or should I put it in the middle back?
Too
That's
much.
too much? Okay, 5 grams. Let's see, it's about 1, 2, 3, okay. Ha!
Okay, you got it. Good enough.
So, plus 1.0, check mark. Wait, I mean, plus 1.0, check mark, check mark.
Put a line through that.
Yep.
Okay, good. Remember, this book is for you, and you understand everything you do on it.
Yes, I do. And this one. There we go.
Okay, now the lid won't stick when you
Yep, have to make sure to...
put it back on again.
Okay. So, now we add a little of DPNB to this one.
Correct.
Which is this. And propylene glycol, which is this.
Good,
To
good.
the other one.
All right.
So, 5 grams. There we go. Now this one can't overshoot as much. Can I use this? Or will that go too slow?
Yeah, you can use a syringe, disposable pipette it's called.
Disposable pipette.
They'll hold about 2 grams.
I was looking for something to cut it.
A knife? How about
A knife would work, scissors would be good too. Thank you. Handy dandy knife. Wait, does yours have scissors?
Yeah, but
That's not scissors. Where's the scissors?
they're hard to get.
Oh, okay, well, a knife will work. That's not a knife. But it works.
Probably don't need a knife for solvent.
Probably not. Okay, so
It usually holds 2 grams, the whole syringe.
okay, so we've already tared it, and this is the NPB to this one. I didn't fill it up all the way. Don't think it will fill up all the way. 2.2, and we need 5. 3. So I guess this one holds 1 gram. So I'm not filling it up all the way. 4. About 4 drops more. And about 5. Yay!
Okay, you better take a stir stick and stir it right away. Usually we do this under agitation.
Okay. Don't want it to come out. There we go. Because the top part was so liquid, it had low viscosity, I didn't want to splash out.
Good thinking. Okay. Looks like it's mixed in. Good for you. Just leave the stick in it and put it back on the balance.
Okay, it seems about mixed in. There we go. Okay, so I got the 5. Check. Tear. Okay. Now we put in the propylene glycol. 5 grams. Let's use this one. So 1 gram. Two grams. I don't think this is going to be a complete gram. No, maybe it is.
You're getting there.
Almost.
Now see, what we're expecting is that the DPNB, very strong, strong solvent to dissolve the acrylic, will soften the acrylic beads, micelles in there, and make it fuse together and form a film. But the propylene glycol, very weak solvent, doesn't dissolve hardly anything, and it won't make it. So there's a lot of techniques going on here.
Well, that definitely mixed in a lot easier than the other.
Yeah, because it wasn't penetrating the micelle.
Right.
It's floating around in the water phase, in fact, because it's soluble in water, and just kind of stays happily in there, doesn't attack the micelles, doesn't dissolve any of the acrylic. Okay, now we'll do a triple drawdown.
Okay. Hold on, let me get my paper from phone book.
Okay, this is the drawdown paper. This is called the catch paper.
There.
And phone books make an excellent source of catch paper. Put that under the glass, yes. Good. And notice that the drawdown paper, drawdown chart is just off the edge of the glass so that you don't get the glass wet.
Just slightly.
Okay, so now you put a small puddle of paint on each spot there. probably dip that out with a...
Yeah, I was about to say, I don't
stick.
want to pour this, because this is still, you know, top heavy. It's difficult to control how much exactly is pouring out. Okay, so, put some right there. And a little more right there. Ah!
Oh, you got it good enough.
Okay, that sound looks good to me.
Yep, that's...
Okay.
Yeah, that's it, all right. 2A is right in place.
2A.
And here's 2B.
Here's 2B, that's so much thicker.
Yeah, 2B has the coalescing solvent in it.
Is that about right?
Yep.
2B. And now 2C, nice and flowy.
Yeah, it's been diluted by the solvent.
Okay, I think all is ready.
Yep.
Okay, now we do our drawdown.
With a 3 mil blade.
With a 3 mil blade. Okay, and go.
Very nice and smooth. Okay. Now write the time down, please, on where it says time.
It is 2:41.
Because we want to see how long it takes for this to dry. Okay, so we want to make, what's the next one? Because we have 3 more formulas. You can probably just leave that. Oh, that's right, we have to clean this.
Yeah, always clean this one. Right?
Yeah.
Usually I'd run it under a sink.
We can either clean it with water or we can just wipe it down.
I'm going to go clean it in the sink.
Okay. Okay, we're back online.
We're back. This is all clean now.
And the bar has been cleaned.
Yep, all nice and clean. Okay, so now we're going to do another drawdown of 2D, 2E, and then 2F.
Okay.
And 2D is just this one, wait, is this one actually? Where did it go? This one.
Okay.
This one's 708E.
708E is a medium
Yep.
hardness resin because its T sub G is right around room temperature. Depending on what room temperature is. It's right about 77 Fahrenheit. It'll form a film sometimes, not sometimes.
Okay, so that one will just go there. And then this one, this is 2E, CAE2E, is the DS6183. Where is it?
Right in front of you.
No, this one's...
To the right of that.
Ah! Ah, there it is.
Yep.
I see it now. Okay, so this one's D, this one's E, and now we're going to make F. So F calls for a 25% of DPNB, but because we have only this small container, we made it a half. So we're going to put 50, well, first tear it, 50 grams of 604A. If I can get, wait, should I just use this?
Nope.
No. 50 grams. Doo-doo-doo-doo. Almost there. 40. 10 more and... Hold on. One.
Wow. Very nice.
Thank you.
50.
That takes skill.
Okay, be sure to write down your point 1.
Yes, always keep track of point 1. Okay, right here, plus 0.1. I added it, so I check it off.
Good.
Okay, now I have 12.5 grams of the here. Okay, so tear. Okay.
You can just pour it in. It's not critical if you come within a gram or 2.
Okay, so 12.5.
Actually, a way to pour that without it.
Yeah.
A way to pour that
Without,
if you
see,
pour
because it catches the
over
room.
the top, then it'll pour better.
Oh, that's interesting.
Yeah, that way that the angle coming out is more of a pour over angle. And if you want, you can pick that up and pour in the estimated amount.
Okay. 12. .5, right?
Yes. You got it.
Okay.
12.7.
Yep.
Be sure you put in your extra 0.2.
Check. Check. Now I stir it.
Okay, so we stir it up. Let's see what it looks like.
Okay, right now it's moving rapidly, see?
Mm-hmm.
It's starting. Ooh, look at that!
Uh-oh, what happened?
Look at that!
Whoa, that's not good. So that's what happens with an overdose. Quick, get some on the drawdown there so you can, before it turns too solid. Okay, that'll show.
You think? Okay.
Yeah.
And then...
Well, we see what happens when you put in too much co-solvent. You get instant plastic.
Here's this one. Do I need a little more?
Yes. Okay, so that's the medium resin, the B708E.
Okay. And then here's this one.
There's the soft resin, the Acronal. Okay, so this one we will dry at room temperature also. And then later on, I'll do some cold and warm.
Okay. And our phone book, our handy dandy phone book.
Just think you might someday pull the phone book page out and see someone you know.
I'm still waiting because I'm in the beginning chapters. There. Okay, and now the bar, which goes like so. And, okay, draw down. Whoops. We didn't do that.
Whoops.
Well,
that's why you want it to hang over the glass.
Yeah. Forgot about that.
Okay, let's see how these are coming along. Looks like, wow, these room temperature ones, looks like they're all starting to form.
And where did my paper towels go?
Form crystals. These are forming crystals. They're supposed to flow out.
Alright.
Well, we'll see what happens. Maybe, so 10% might not be enough for this this real hard resin. Might need to put in more. But this is how you find out.
Indeed. I like the plastic. Isn't that cool?
Yeah. You don't put that down the sink.
No, not at all. That one we wipe off.
Okay, well, that's our first part of the lab. Thank you, Juliet.
Yep.
And then we'll get into making these, put them in the refrigerator and in the oven.
Sounds good.
Okay, here we have the result of the coalescence test. And this panel here, the first panel, has the CAE2A. That experiment had the B604A by itself. And B604A had a real high T sub G, so it's a hard resin. And as you can see by itself with no co-solvent, it has crystals all over it. Just room temperature, because its T sub G is higher than the room temperature. See if we can find some crystals. Yeah, see that crystal structure there? Lines running all through it. And it's milky. But the one right next to it, we put in 10% of DPNB. That's the CAE2C. That has 2B, CAE2B. That has 10% of DPNB, a very slow evaporating, rich, strong solvent which solubilizes acrylics very well. And you can see it's glossy. It's this one right here. This has no co-solvent, and this has 10% on solids. Since it's about a 50% solid, so we add 5%, that makes it a 10% of the solid content. Now to see the significance of a poor co-solvent, which would be propylene glycol, which does not dissolve the acrylic, you can see that it has 10% of propylene glycol, and it also has the crystallization, which the zero co-solvent had. So here's DPNB, and here's the propylene glycol. Propylene glycol does not lower the T sub G, so that at 77 Fahrenheit it will coalesce into a film. So we also did this experiment here. Here's 2B again, which is a 10% of DPNB, because even though it helped, it wasn't enough. So this is how we find out. Will it form a film at room temperature or not? So I put in another 5% on solids. That's 2G. And we can see here that this film here is much stronger than this film here. This film still has some crystallization, and this has more of a glossy, intact film. Then to see the effect at, and this was also cured at 77 Fahrenheit. So then to see the effect of the T sub G being with medium B708E, its T sub G is right around room temperature. What happens if the temperature that it's cured at is lower, like around 40 Fahrenheit? So this was put in the refrigerator overnight, and you can see all the crystal structure. Wow. Not only the crystal structure, but it if you drop it, it'll just shatter right off the panel. However, here's a soft resin that has a T sub G of 0, which is very close to 40 Fahrenheit. Actually, 0 Celsius means 32 Fahrenheit. So this is right borderline, and you can see it's half crystalline and half resin. This is intact here, but not here. See how the flake's off right there? And this is intact. That means some parts of it would form a film. Not a very strong film, because the polymers themselves don't get a chance to migrate into the adjacent micelle. So that's the story.